If it is 3, we are going to write 3 times a to the power of n minus 1. Since there are n number of terms, so therefore this can be written as n into a to the power of n minus 1. So 1 can also be written as limit x tends to 1 of x to the power of 15 minus 1 to the power of 15. 1 to the power of 15 is 1. What is the substitution? We have taken y is equal to 1 plus 6. When x tends to 0, when x is equal to 0, when x tends to 0, y also tends to 1. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss very important concept, that is limit of a function. In this I am going to discuss very important theorem, that is theorem on limits. So very important theorem for the point of examination. Now let us come to the theorem number 1. First theorem. Prove that for any positive integer n, limit x tends to a of x raised to n minus a raised to n by x minus a is equal to na to the power of n minus 1. Actually here the three cases arises. When n is a positive integer, n is a negative integer and a fraction, positive or negative fraction. So therefore n is a rational number. So here we are going to prove this for n is a positive integer. Now let us come to the proof. Let n is a positive integer. Let n is a positive integer. Now if we divide x raised to n minus a raised to n by x minus a, we are going to get the factors as x minus a into x to the power of n minus 1 plus x to the power of n minus 2 into a plus x to the power of n minus 3 into a square plus etc. The last term is a to the power of n minus 1. Right. Now substitute here. So therefore limit x tends to a of x raised to n minus a raised to n by x minus a can be written as limit x tends to a of, in the numerator, x raised to n minus a raised to n can be written as x minus a into x to the power of n minus 1 plus x to the power of n minus 2 into a plus x to the power of n minus 3 into a square, etc. The last term is a to the power of n minus 1 whole divided by x minus a. Now cancel the terms which gets cancelled. So here x minus a and x minus a gets cancelled. So what we have, limit x tends to a of x to the power of n minus 1 plus x to the power of n minus 2 into a plus x to the power of n minus 3 into a square, etc. The last term is a to the power of n minus 1. Now apply the limit. Put x is equal to a. If you put x is equal to a, this is equal to a to the power of n minus 1 plus a to the power of n minus 2 into a plus a to the power of n minus 3 into a square, etc. The last term is a to the power of n minus 1. So applying law of indices, we know that a to the power of m into a to the power of n is a to the power of m plus n. So this a to the power of n minus 1 as it is, a to the power of this is plus 1, minus 2 plus 1 is a to the power of n minus 1. Again a to the power of n as it is, minus 3 plus 2 is minus 1, etc. The last term is a to the power of n minus 1. Suppose if there are two terms, you can write 2a to the power of n minus 1. If it is 3, you are going to write 3 times a to the power of n minus 1. Since there are n number of terms, so therefore this can be written as n into a to the power of n minus 1. That is the proof. So therefore conclude that limit x tends to a of x raised to n minus a raised to n by x minus a is equal to na to the power of n minus 1, where n is a positive integer. So therefore limit x tends to a of x raised to n minus a raised to n by x minus a is equal to n into a to the power of n minus 1, where n is a rational number. Positive integer, negative integer, or a fraction. This is how we are going to derive this theorem. Very important for the point of examination. Hope you followed. Okay. Now based on this, let us discuss few examples. Now move on to the first problem. Evaluate the following limits. Limit x tends to a of x raised to x cube minus a cube divided by x minus a. Now, if you observe carefully, this is of the form limit x tends to a of x raised to n minus a raised to n by x minus a. What is the formula? N into a to the power of n minus 1. Here n is equal to 3. So, comparing with x raised to n minus a raised to n by x minus a, what is n? N is 3 and a is a itself. Apply the formula n. N is 3 into a to the power of 3 minus 1, that is 3a to the power of 2. So, this is equal to 3a square. Suppose if it is like this, same problem, limit x tends to 2 of x to the power of 3 minus 2 to the power of 3 divided by x minus 2. Instead of a, it is 2. So, what is n? N is equal to 3 and a is equal to 2. What is the formula? N into a to the power of n minus 1. N is 3 into 2 to the power of 3 minus 1. 3 into 2 to the power of 3 minus 1 is 2. That is 3 into 2 square is 4. This is equal to 12. The required answer is 12. On the other hand, suppose, so if it is like this, x raised to 3 minus, limit x tends to 3 of x cube minus 2 cube divided by x minus 2, that is nothing but limit x tends to 2 of x to the power of 3 minus 2 to the power of 3 divided by x minus 2, we are going to get the answer 12. Suppose if it is like this, similarly, if it is limit x tends to 2 of x to the power of 6 minus 2 to the power of 6 divided by x minus 2. Now, this is also similar type. What is n here? Here n is equal to 6 and a is equal to 2. Na to the power of n minus 1. What is n? 6 into 2 to the power of 6 minus 1. 6 into 2 to the power of 5. That is equal to 6 into 2 to the power of 5. 2 to the 4, 4 to the 8, multiplied, 2 to the power of 5, 2 into 2 into 2 into 2. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. Multiply this. This is equal to 2 6 are 12, 6 3 are 18 and 9 192. 32 6 are 192. So, this is how we are going to simplify this type of problems using the formula limit x tends to a of x raised to n minus a raised to n by x minus a is equal to na to the power of n minus 1. In this case, n is a positive integer. Now, move on to a similar type problem. Now, here what is given? Limit x tends to 2 of x cube minus 2 divided by x square minus 4. If you observe carefully, this is of the form limit x tends to of x raised to n minus a raised to n by x raised to n minus a raised to n. Now, convert this into the standard form first. Now, this can be written as limit x tends to 2 of x cube minus 8 can be written as 2 cube divided by x square minus 4 can be written as 2 square. Now, if you observe carefully, this is of the form x raised to n minus a raised to n divided by again x raised to n minus a raised to n. Convert this into the standard form. For this, divide by x minus 2 both in numerator and denominator. So, what you will get? Apply the limit. Limit x tends to 2 of the numerator is x cube minus 2 cube divided by x minus 2. In the denominator, x square minus 2 square divided by x minus 2. So, if you observe, this is of the form limit x tends to a of x raised to n minus a raised to n by x minus a. Denominator also limit x tends to a of x raised to n minus a raised to n by x minus a. In the numerator, what is n? N is 3, a is 2 to the power of 3 minus 1. In the denominator, n is 2, a is 2 to the power of 2 minus 1. So, this is equal to 3 into 2 square divided by 2 into 2 to the power of 1. So, 3 into 2 square is 4 divided by 2 2s are 4. So, 2 square is 4. What happens? 4 and 4 gets cancelled. That is equal to 3. The simplified answer is 3 is the answer. That is it. The required answer for this is 3. That is it. Okay. So, convert this into the standard form x raised to n minus a raised to n by x minus a and limit x tends to a. Divide both numerator and denominator by x minus 2 and apply the limit. You will get the answer. 4 4 gets cancelled 3. Suppose if it is like this, similarly, limit x tends to 1 of x to the power of 15 minus 1 divided by x to the power of 10 minus 1. So, this can be written as So 1 can also be written as limit x tends to 1 of x to the power of 15 minus 1 to the power of 15. 1 to the power of 15 is 1. In the denominator, x power 10 minus 1 power 10. Now again this is of the form x raised to n minus a raised to n by again x raised to n minus a raised to n. Divide by x minus 1 and apply the limit. Limit x tends to 1 of x to the power of 15 minus 1 to the power of 15 divided by x minus 1 whole divided by x to the power of 10 minus 1 to the power of 10 divided by x minus 1. Now apply the limit. In the numerator, n is 15. 15 into 1 to the power of 15 minus 1. In the denominator, n is 10. 10 into 1 to the power of 10 minus 1. So 15 into 15 minus 1 is 14. So 1 to the power of 14 is 1. Again 10 into 1 to the power of 9 is 1. So 15 by 10. 15 by 10 also 15 by 10 can also be written as divide by 5. 5 3 is a 5 2 is a 3 by 2 is the required answer. That's it. Okay. Now suppose if it is like this. Similarly, if it is limit x tends to minus 1 of x cube plus 1 divided by x plus 1. Now observe carefully, this is of the form x raised to n plus a raised to n. Now convert this into x raised to n minus a raised to n divided by x minus a. So therefore this can be written as limit x tends to minus of x cube. This can be written as minus of minus 1 divided by minus of minus 1. Minus into minus plus. So limit x tends to minus 1 of x cube minus 1 can also be written as minus 1 whole cube divided by minus 1. What is minus 1 whole cube? Minus into minus into minus, it is minus itself. So if you observe carefully, what happens? Minus into minus plus, minus into minus plus you will get. So what is n here? N is equal to 3 and a is equal to minus 1. N a to the power of n minus 1. N is 3 into minus 1 to the power of 3 minus 1. N a to the power of n minus 1. 3 into minus 1 whole square. That is 3 into minus 1 whole square is 1. That's equal to 3. The simplified answer is 3. That's it. Okay. Hope you followed. Now move on to the next problem. This is very important problem. Evaluate limit x tends to 0 of root of 1 plus x minus 1 divided by x. This can be solved in two methods. Let me explain method 1. First one. In the first method, whenever a root problem is given, rationalize the numerator. Limit x tends to 0. Root of 1 plus x minus 1 divided by x. Just multiply both numerator and denominator by root of 1 plus x plus 1 divided by root of 1 plus x plus 1. Rationalizing the numerator. So this is limit x tends to 0 of root of 1 plus x into root of 1 plus x is root of 1 plus x whole square, minus into plus minus 1 square is 1 into denominator divided by x into 1 plus x plus 1. Now this is equal to limit x tends to 0, square and square root gets cancelled, 1 plus x minus 1 divided by x into root of 1 plus x plus 1. So minus 1 plus 1 gets cancelled. This is equal to limit x tends to 0, x divided by, in the denominator we have x into root of 1 plus x plus 1. So x and x gets cancelled. Apply the limit. We put x is equal to 1 divided by root of 1 plus 0 plus 1, that is 1 divided by root of 1 is 1 plus 1, that's equal to 2. The simplified answer is 1 by 2. So this is first method, that is just rationalizing the numerator, multiply both numerator and denominator by root of 1 plus x plus 1 divided by root of 1 plus x plus 1. Root of 1 plus x into root of 1 plus x is root of 1 plus x whole square, minus into plus it is minus, 1 square is 1 square, square root gets cancelled, multiply by negative sign, this as it is, 1 plus x minus 1, cancel that terms, minus 1 plus 1 gets cancelled. What we have in the numerator, x divided by in the denominator x into root of 1 plus x plus 1, cancel the terms, both x and x it gets cancelled. Now put x is equal to 0, 1 by root of 1 plus 0 is 1 plus 1 is equal to 2. This is one method. Now on the other hand, method 2, second method is, so let me explain the second method. Second method by the method of substitution. Let us consider this as put y is equal to 1 plus x. Y is equal to 1 plus x. Then what happens? Whenever the substitutions are taken, the value of limit changes. So, when x is equal to 0, when x tends to 0, y is equal to 1 plus 0 is equal to 1 means, so when x tends to 0 implies y tends to 1. So, the given limit becomes limit y tends to 1 of root of 1 plus x can be written as y minus 1 divided by in the denominator. So, this implies if we transfer y minus 1 is equal to x. So, this becomes y minus 1. So, this can be written as limit y tends to 1 of y root y can be written as y to the power of 1 by 2 minus 1 can also be written as 1 to the power of 1 by 2. Root of 1 is 1 itself divided by y minus 1. So, if you observe carefully, this is of the form limit x tends to a of x raised to n minus a raised to n by x minus a is equal to n into a to the power of n minus 1. What is n here? 1 by 2. 1 over 2 into 1 to the power of 1 by 2 minus 1. 1 by 2, 1 to the power of 1 minus 1 by 2 minus 1 is minus 1 by 2. 1 by 2, bring this to the denominator, it becomes 1 to the power of plus 1 by 2 is nothing but root of 1 is 1, that's equal to 1 by 2. The simplified answer is 1 by 2. Any method you can do by direct rationalizing the numerator or denominator or by the method of a substitution. But keep in mind, whenever the substitutions are taken, the value of limit also changes. In this case, what is the substitution we have taken? Y is equal to 1 plus x. When x tends to 0, when x is equal to 0, when x tends to 0, y also tends to 1. So, limit x tends to 0 becomes y tends to 1. Root of y is y to the power of 1 by 2 minus 1 is 1 by 2, 1 to the power of 1 by 2. And if you transfer x can be written as y minus 1, apply the limit, you will get the answer as 1 by 2. This is how we are going to solve this problem. Okay. Now, move on to the next problem. Limit z tends to 1 of z to the power of 1 by 3 minus 1 divided by z to the power of 1 by 6 minus 1. Now, this can be written as limit z tends to 1 of z to the power of 1 by 3 minus 1 to the power of 1 by 3. 1 to the power of 1 by 3 is 1. In the denominator also, z power 1 by 6 minus 1 to the power of 1 by 6. Now, observe carefully, this is as that of the previous problem. So, x raised to n minus a raised to n by x raised to m minus a raised to m. Convert into the standard form by dividing both numerator and denominator by z minus 1. Z to the power of 1 by 3 minus 1 to the power of 1 by 3 divided by z minus 1 whole divided by z to the power of 1 by 6 minus 1 to the power of 1 by 6 divided by z minus 1. Apply the limit, that's all. Okay. Now, if you apply the limit, this is equal to, what is n? 1 over 3 a n, yes, limit x raised to n minus a raised to x minus a is n a to the power of n minus 1, 1 by 3, 1 to the power of 1 by 3 minus 1 divided by 1 by 6, 1 to the power of 1 by 6 minus 1. This is 1 to the power of 1 minus 3 is minus 2 by 3 divided by 1 by 6, 1 to the power of minus 5 by 6. Whatever it may be, if you interchange this to the numerator, this becomes 1 over 3. Take this to the numerator, 1 to the power of plus 5 by 6, 1 over 6. This becomes, so this is 1 over 3 into 1 divided by 1 over 6 into 1. So, this is nothing but 1 by 3 into 6 by 1, that's equal to 2. The simplified answer is 2, that's it. The required answer is 2 in this case. Okay, right, very simple. Just convert into the standard form by dividing numerator and denominator by z minus 1 and apply the limit. So, 1 to the power of any number is equal to 1, 1 by 3 divided by 1 by 6, take to the numerator, interchange, reciprocate it, 1 by 3 divided by 1 by 6, take 1 by 6 to the numerator, 6 by 1 gets cancelled, you will get the answer as 2. Okay. Similarly, there is one more problem like this. Similarly, suppose if it is limit x tends to 9 of x to the power of 3 by 2 minus 27 divided by x minus 9. So limit extends to 9 of limit extends to 9 of x to the power of 3 by 2 minus 27. How to write 27? 27 can be written as 3 cube. This can also be written as 3 square whole to the power of 3 by 2. So 2 gets cancelled. You will get 3 cube is 3 3s are 9 3s are 27. So this can be written as, what is 3 square? 3 square is nothing but 9 to the power of 3 by 2. So this can be written as 9 to the power of 3 by 2 divided by x minus 9. Now if you observe carefully, this is limit extends to of x raised to n minus a raised to n by x minus a. The important step is, this is the important step. So that is 27 can be written as 2 cube. 2 cube can also be written as 3 square whole to the power of 3 by 2. So 2 gets cancelled, 2 cube. What is 3 square? 3 square is 9. So 27 can be written as 9 to the power of 3 by 2. Now what is n? N is 3 by 2 into a. A is 9 to the power of 3 by 2 minus 1. 3 by 2 into 9 to the power of, take LCM, 2 is the LCM, 3 minus 2 is 1 by 2. So that is 3 by 2 into 9 to the power of 1 by 2 is nothing but root 9. So what is the square root of 9? Square root of 9 is 3. 3 3s are 9 divided by 2. So the required answer for this is 9 by 2. That's it. Hope you followed. Okay. So this is how we are going to solve the problems based on theorem number 1. That is, so limit extends to of x raised to n minus a raised to n by x minus a is always equal to na to the power of n minus 1, where n is a positive integer or a negative integer or a fraction, positive fraction or a negative fraction. So in general, for a rational number. So that's it. Hope you followed. These are few problems based on theorem number 1. So that's all regarding today's session. Let us meet with the different type of problems, different concept in the next session. Thank you. Thank you very much.